Today we are discussing about Faraday's laws. Faraday's laws of electromagnetic induction. It explains the relation between electrical circuit and magnetic field. This law is basic working principle of the most of the electrical motors, generators, transformers, inductors, etc. Now you can see the image how the flux and EMF are going to be appear on a conductor which is placed in the magnetic field. Faraday's law of electromagnetic induction principle is specified or is explained in two ways. That is, which is called as Faraday's first law. Whenever a conductor is placed in a varying magnetic field, an EMF gets induced across the conductor called as induced EMF, and if the conductor is a closed circuit, then induced current flows through it. Magnetic field can be varied by various methods. By moving magnet, 2. By moving the coil, 3. By rotating the coil relative to the magnetic field. Faraday's second law. It is the second law of Faraday's electromagnetic induction. It states that magnitude of induced EMF is equal to the rate of change of flux linkages with the coil. The flux linkages is the product of number of turns and the flux associated with the coil. Formula of Faraday's law. Consider the conductor is moving in magnetic field, then flux linkage with the coil at initial position of the conductor is equal to N into phi 1 Webers, where N is speed of the motor and phi is the flux. Flux linkage with the coil at final position of the conductor is equal to N into phi 2 Webers. Change in the flux linkage from the initial to final is equal to N of phi 1 minus phi 2. Let phi 1 minus phi 2 is equal to phi. Therefore, change in the flux linkage is equal to N into phi. And rate of change in flux linkage is equal to N phi by T. Taking the derivative of the RHS, rate of change of flux linkage is equal to N into d phi by dt. According to Faraday's law of electromagnetic induction, the rate of change of flux linkages is equal to the induced EMF. So, E is equal to N into d phi by dt volts.